right, so today we are dividing polynomials. What we have done so far is simplify polynomials. So for example, if I gave you the fraction, I don't know, let's say 9/24, and I wanted to reduce this fraction, what do? I find a common factor, right? And then I just reduce by that common factor. So what's my common factor here? 3. So 3 goes into 9 3 times, 3 goes into 24 8 times, so I reduce it to get 3/8. Okay, so that's essentially what we were doing in the last section. We would factor our polynomials, reduce any common factors, and whatever was left was our reduced fraction. Okay, now let's say I wanted to do something like, how about 153, oops, that's not a 3 at all, 153 divided by 50. Does that reduce? No, they don't have any common factors, but I can divide the two. It's not going to come out evenly. I'm going to have a remainder. Do you remember this from way back when? Yes, so I'm going to remind you of the steps of long division. Let's see what we remember.
Wait, a remainder? I thought we just did it as decimal.
No, remember in elementary school you would have a remainder of some number?
Yeah.
You would divide the two and there'd be a remainder?
Yeah,
Okay.
We're just doing that because we were done with the keys.
Well, let's try this. So remember first of all how I would set it up. If I have this divided by this, I would take the denominator. It's now my, well, it's really called the divisor, right? And I put it on the outside, and then I have the dividend on the inside. And then how did you go through this process? Do you remember?
Yeah, you find what 50, like, what's the most it goes into 153, and then you put it on top of, like, the last number that you, or in this case, it's the last number.
Right. How many times can 50 go into 153? 3 whole times. And then didn't we take this number and multiply by what's out in front?
Yeah.
Remember that? Okay, so 3 times 50 is 150. And then what did I do?
Subtract.
You subtract the 2, and I'd get a 3. And now you could go into decimal, right? You could put decimals here and then keep bringing them down. Or you could just say, okay, it's a 3 with a remainder of 3. Do you remember that?
Yeah.
Now, how else can you write that, though? Instead of writing R3, yes, it's 3 and whatever the remainder is over the divisor. So 3 and 3/50 is what we would get if I divided 153 by 50. Turns out the steps are really similar when we're doing this with
Yeah,
polynomials.
that's not what I remember. I just remember we just like write lowercase r and then like.
Well, that's okay. Stay with me and you'll learn. All right, so let's try a couple of things that we have to talk about before we jump right into this. So, when dividing polynomials, I want to make sure that all degrees are accounted for. I'll show you what I mean in a second. Oops, let's spell degrees right. Degrees are accounted for.
Just remind me what's degrees.
That's your exponent for each term. So for example, let's say I wanted to do, I don't know, I'm just going to make something up. X plus 2, and I want to divide that into, let's say, x to the third plus 2x plus 1. Well, there's a problem with this. Before I can continue, I need to make sure that I have all degrees represented. So if I take a look here, I'm starting off with x to the third. So if the degree of the entire polynomial is 3, that means I need to have a term for every degree below that. So I have an x to the third term. Do I have an x squared term?
No.
No, I don't. So what I need to do is put in what we call a 0 placeholder. Do I have an x to the first term?
Yes.
Yes, I do. It's already there. Do I have an x to the 0 term?
Yes.
Yes, it's already there. So what I actually need to do first is I need to rewrite this. And I'm going to put in a 0 placeholder. I'll show you how it looks. I had x to the third. I did not have x squared, so I put in a 0x squared. And then plus the 2x plus the 1. So now every degree is accounted for. X to the third, x squared, x to the first, and then no x at all.
What if you just have x squared, and then you don't have x to the first?
You do the same thing, yep. So This is a critical step because everything needs to line up. If you don't have the zero placeholder, it's kind of going to break. Now, as far as out here, you actually have a little bit of leeway. I highly recommend putting in a zero placeholder over here if you need to, just because it's going to help you keep everything set up. It won't, I would recommend you do it anyway. So here, my highest exponent is x to the first, and I have that. Do I have x to the 0? Yes, I do. So I don't need a zero placeholder out here. It's already done. But I needed one there, and you'll see why in a moment. Okay? All right. So now my process is very similar. Remember what I did up here. I asked myself, okay, well, how many times can 50 go into 153? What I'm going to do is I actually think it's easier to think of it in terms of multiplication. Take a look at your very first term. It's just x. And here's what you're going to ask yourself. What do you multiply x by to get x to the third? X squared. So what I'm going to do is I'm going to write it on top, and I'm going to keep everything. See where I'm writing it? I'm writing it above the x squared term. I want to keep everything in line. All my x squareds will be here. All my x's will be here. All my single numbers will be here. So far are we okay? I asked myself, what do I multiply x by to get x to the third? The answer was x squared. Now, just like I did up here, once I figured out it was 3, didn't I multiply 3 by 50? And I wrote down here. I'm going to do the same thing. I need to do x squared times, since this is a binomial, I have to multiply by both of them. So what is x squared times 2? So I write it underneath here in the x squared column. I'm keeping everything lined up. Now I have to do x squared times x, and that gets me x to the third. Now, what did you do up here once I did that? I did 3 times 50, then I subtracted it. Here's something that's tricky, and you have to pay attention. Both of these now need to be subtracted. So you are now a minus, and so are you. You have to minus the whole line.
Are they like separate?
Yeah, they're so because they're not like terms. So
I mean, like, are they within the same like line?
yes, you put them right on the same line. So now I'm going to subtract these two things. What's x cubed minus x cubed? 0. That should always happen. That first term should always cancel out. That's math helping you out. That's a little self-check as you go through. That's just a sign that says, hey, you're doing all right. What is 0x squared minus 2x squared? Negative 2x squared. Okay? Now in this scenario, I have more things over here. What do you think I do now? I bring it down. So I'm going to bring down a plus 2x. And then I basically repeat the process. So I'm going to ask myself, what do I multiply x by to get negative 2x squared? Negative 2x, right? So that goes up top in the x column, negative 2x. Do you see how this is working? Now I'm going to take negative 2x and I multiply by what's out in front. So what is negative 2x times 2? Negative 4x, right? So I write it down here in the x column, negative 4x. Thank you. And then let's do the negative 2x times x is negative 2x squared. But then what am I supposed to do with this line? Now you subtract them both. Since they're already negatives, what actually happens to them? They both turn positive.
Wait, I have a question.
Yep.
How did you get the negative 2x squared? Like, can we rewind?
That was right there.
Yeah.
I took negative 2x and I multiplied it by x.
Oh, okay.
Okay, so now I'm subtracting both. That turned them both into pluses. Look what happens again. What's negative 2x squared plus 2x squared? They cancel out. Thanks, math.
You're welcome.
Yeah. So now that's a little self-check. That's just reminding you, okay, you're doing things right. Keep going. What is 2x plus 4x? 6x. Bring down the plus 1. Whoops. And then I repeat the process again. So what's the question I'm going to ask myself now? Perfect. What do I multiply x by to get 6x? Positive 6. So I put it up top in the single number column, right? So now I take positive 6 and I'm going to multiply it by my binomial out in front. So 6 times 2 is a positive 12. 6 times x is a positive 6x, but now what do I do? Now you subtract them both. So I'm really going to minus u, and I'm going to minus u. 6x minus 6x, gone. That's exactly what's supposed to happen. And then 1 minus 12, negative 11. There is nothing left for me to bring down. So that's my remainder. So how do we write it? I'm going to go back up here. Since it's a negative 11, I'm going to write it as minus 11 over x plus 2. And this whole top thing here, let me switch colors, this is your answer to that problem.
It's quite an answer.
It is, but
You don't have to simplify.
no, that's it.
Yay.
You are done. So let me stop this video here to keep them short.